So here we have to determine whether each of the following relations are reflexive, symmetric, and transitive. So we know that if A comma A belongs to a relation R, then the relation R is reflexive. And if A1 comma A2 belongs to the relation R, also implies that A2 comma A1 also belongs to the relation R, then the relation R is symmetric. And if A1 comma A2 belongs to relation R, and also the element A2 comma A3 also belongs to the relation R, then A1 comma A3 should also belong to the relation R. Then it is no. So this also implies that A1 comma A2 A3 belongs to the relation R. Then the relation R is transitive. The relation R is transitive. Now, the relation R in the set A is defined as R x comma y, where 3x minus y equal to 0. So it means that y equal to 3x. So here we can see that suppose we take, so same number cannot be related. So it means that here a comma a does not belong to the relation R. Since why a cannot be equal to 3a. Since 0 is not an element of the set A. So I can say that so only 0 comma 0 could have been uh, an element of R, but since 0 is not an element of the set A, so a comma a does not belong to the set R. Okay, so R is not reflexive. So this rule we have to use for every case in this question number 1. So this is the rule. So R is not reflexive here. And so here we can see, suppose for example, 2 comma 6 belongs to the relation R, but 6 comma 2 does not belong to the relation R. So I can say that the relation R is not symmetric. And suppose here 1 comma 3 belongs to the relation R, and also 3 comma 9 also belongs to the relation R, but 1 comma 9 does not belong to the relation R. So I can say that the relation R is not transitive also. So the relation R here, it is neither reflexive nor symmetric or transitive. In the question number 2, here y equal to x plus 5, x is less than 4. So here suppose for example if I say that uh, R is the set, R in the set of natural numbers. So this relation R is on the set of natural numbers only. So only natural numbers can be used. So if I take x equal to 1, then y will be equal to 6. So 1 comma 6 belongs to the relation R. But 6 comma 1 does not belong to the relation R. But then so 6 comma 1 does not belong to the relation R. Hence we can say hence the relation R is not symmetric. Relation R is not symmetric. Also, same element cannot be used. Suppose, for example, A comma A. A comma A does not belong to the relation R for all A belongs to N. So relation R is not reflexive. It is not reflexive also. And also, suppose for example here 1 comma 6 belongs to the relation R, and also 6 comma 11 also belongs to the relation R, and also 6 comma 11 also belongs to the relation R, but 1 comma 11 does not belong. I can say that 1 comma 11 does not belong to the relation R. So I can say that relation R is not transitive also. So it is neither reflexive, nor symmetric, nor transitive. Then the third one, y is divisible by x. The third one, here a is 1, 2, 3, 4, 5, 6. And y is divisible by x. So I can say that a comma a belongs to the relation R for all a belongs to the set A. Since a is divisible by a, since a is divisible by a, so I can say, so the relation R is reflexive. And here, suppose for example, 2 comma suppose 1 comma 2 belongs to the relation R, and 1 comma 5, okay, so and 1 comma 6, or suppose for example 2 comma 6 also belongs to the relation R, and this also implies that 1 comma 6 also belongs to the relation R. So I can say that the relation R is transitive. And also since 6 is divisible by 2 and 2 is divisible by 1, so 6 is also divisible by 1. Also we can say that, also suppose 3 comma 6 belongs to the relation R. Since 6 is divisible by 3, since 6 is divisible by 3, but 6 comma 3 but 6,3 is not divisible. But 6,3 does not belong to the relation R, since y 3 is not divisible by 6. By 6. So the relation R is not symmetric. So it is reflexive and transitive but not symmetric. Then x minus y is an integer. R in the set Z of all integer is defined as x minus y is an integer. So now the fourth one. So R is a relation from Z to Z. It is on the set Z. So now x minus y is an integer only. So therefore x comma y belongs to relation R. This also implies that y comma x also belongs to the relation R. So the relation R is symmetric. Also, x comma x also belongs to the relation R, since x minus x equal to 0, which is an integer. So the relation R is reflexive. And also, if x1 comma x2 belongs to the relation R, and also x2 comma x3 belongs to the relation R, then x1 comma x3 also belongs to the relation R. Hence we can say that since by integer minus integer is always an integer only, so therefore the relation R is transitive also. So here in the fourth one, the relation is reflexive, transitive, and symmetric. So in the fourth one, this relation is a equivalence relation. And then the fifth one, here it is told that relation R in the set A of human beings in a town at a particular time given by. So the fifth one is relation the set A is given, the set of all human beings in a particular town, set of human beings in a particular town in a at a particular time. At a particular time. At a particular time. Now, therefore, A, the set. So we have to form a relation on the set R. So here, actually, R maps from A to A. So now, the part A, for the part A, it has been told that X and Y work at the same place. So X comma Y belongs to the relation R. if x and y work at the same place. So this also implies that y comma x also belongs to the relation R. So the relation R is symmetric. And then the part B is x comma x also belongs to the relation R. Since y, the same human being will work at the same place. The same person will work at the same place. So I can say that the relation R is reflexive. And part C is that if x1 comma x2, so here we can say that x1 comma x2 if x1 comma x2 belongs to the relation R and x2 comma x3 also belong to the relation R, then x1 comma x3 also belongs to the relation R. Since it means that x1, x2, and x3 all work at the same place. So it means since it means x1 and x1, x2, and x3 all work at the same place. All work at the same place. So I can say that the relation R is transitive also. So it is the answer for fifth part A. Then fifth part B. So it has been told that x and y live in the same locality. Since so x comma x belongs to R, since same person should stay at the same locality only. Since x is the same person, it means. So the relation R is reflexive. Then the second part is if x1 comma x2 belongs to the relation R and x2 comma x3 belongs to the relation R. Then x1 comma x3 also belongs to the relation R. Since why it means that all the three persons x1, x2, and x3 all work at the same, all uh, stay at the same, all live in the same locality. Since it means all of them x1, x2, and x3 all live in the same locality. So here the relation R is transitive. And also we can say here the C part we should not write here. It's not C part, it is the second part of part B only. Okay. So also if x1 comma x2 belongs to R, then this also implies x2 comma x1 also belongs to the relation R. Since why? Since both work in the same locality, since both work in the or so both live in the same locality, it means. So therefore R is symmetric also. So here also R is symmetric, reflexive, and transitive. And then X is exactly 7 centimeter taller than Y. So height of X is HX, suppose. It is 16 centimeter taller than Y. So height of Y, height of X, that is 7 centimeter plus height of Y. So it is the fifth part C. Now, therefore, X comma X does not belong to the relation R. Since Y, the same height of the same person can't be 16 centimeter more than his or her own height. So therefore R is not reflexive. And then also, if x1 comma x2 belongs to the relation R, it belongs to the relation R, then it does not imply that x2 comma x2 comma x1 also belongs to the relation R. Since why, if x1 comma x2 belongs to the relation R, then it means that x1 should be equal to 16 centimeter plus x2. So now x2 I can't write it as x1 plus 16. So x1 comma x2 does not belong to the relation R. So R is not symmetric. It's not symmetric. And then if x1 comma x2 belongs to the relation R, and also x2 comma x3 belongs to the relation R, this does not imply that x1 comma x3 also belongs to the relation R. Since why, it means that x2 equal to x1 or x1 equal to x2 plus 16, and here also x2 equal to x3 plus 16. So then x1 will be x3 plus 32. So this we can't take. And then so you can say that R is not transitive also. R is not transitive also. And then X is the wife of Y. 5 part D is told X is wife of Y. So X comma X does not belong to the relation R. So relation R is not reflexive. And if x1 comma x2 belongs to the relation R, then it does not imply that x2 comma x1 also belong to the relation R. Since so I can say, so R is not symmetric. So R is not symmetric, and um, if x1 comma x2 belongs to the relation R, it means that x1 is the wife of x2. Then it does not imply that, and also and then then x2 comma x3 does not belong to the relation R. So I can say that R is transitive. And fifth part E, that is X is father of Y. So X is father of Y. So X comma X does not belong to the relation R. So R is not reflexive. And if x1 comma x2 belongs to the relation R, it means that x1 is the father of x2. Then x2 comma x1 does not belong to the relation R. So R is not symmetric. Relation R is not symmetric. And also, if x1 comma x2 belongs to the relation R and x2 comma x3 also belongs to the relation R, it means that x1 is the father of x2 and x2 is the father of x3. Then it means that x1 comma x3 does not belong to the relation R. It means since Y, then x1 is father of x2, x2 is father of x3. So it means x1 is the grandfather of x3. So x1 is not the father of x3. So it means x1 comma x3 does not belong to the relation R. So R is not transitive. R is not transitive also. So here it means R is not reflexive, not symmetric, and it is not transitive. So in the part D only, we have that R is not reflexive, not symmetric, but it is transitive. And then in C also, and in 5B, it is reflexive also, transitive also, and symmetric also. So here R is, therefore here R is an equivalence relation. Equivalence relation. And in fifth part A, R is transitive, R is reflexive, R is symmetric. So here also R, the relation R is an equivalence relation. So here, okay. So hope you have understood the concept, how to find if a given relation is reflexive, or is it symmetric, or it is transitive. So thank you.